harvesting wind energy made by vehicles. So before I start the presentation, I thought about where can I collect the energy, and so I thought that the cars and buses and subways are moving. So if I put the wind generator over the vehicle, it can produce energy. But after some during the presentation, I'll talk about it. It uses energy to make energy. So I thought about using the wind that by vehicles move. There is a wind produced nearby the vehicles. So I thought about using that wind to harvest that wind and make energy. So there are vehicles that such as cars, buses, or subways. And I researched about my idea, and there were existing ideas about the roadside current. So that on the left image, that is the design by the Pakistan's engineer Sanwal Munir's turbine design named Capture Mobility, and this is already used on Iceland or some countries, and it can make 7 kilowatts per day per one unit. So it is very efficient, and it can give energy for 2 houses per day. And this is the image in the real life. The cars move, and the turbine spins, and it makes electricity. This is calculating the electricity. And also, there is one more existing idea named Enlil, and it makes very high energy, 1 kilowatt per hour. So, and I wanted to use this idea in our real life in Korea, and I thought that there were so many. Sorry about the traffic issues. So cars and buses cannot move in constant speed, and I thought that there can't be many wind made by them. So I thought about the subway. So this is the idea that I thought before my presentation. So I first thought about putting the generator on the subway, but this is using energy to make a little bit of energy. So this is not meaningful. So I changed my idea to put the wind generator on the tunnel. So there is a space between ceiling of the tunnel and the subway, and I can put the generator like this upside down on the tunnel. And if subway passes through the tunnel, the wind makes, and wind spins the generator turbine, and generator can make energy. So the science used in my idea is the generator that turns spinning energy, kinetic energy, and it makes induced current, and there is a commutator that changes the current into DC, the one-way current, and it can be charged or used anyway, and it can be electric energy. So I wanted to calculate the efficiency of the generator, and I found about some things. And first, I need to know the subway speed to know the wind speed. So I found the average speed of subway in Seoul was 50 kilometers per hour. So the highest speed that subway can move is 80 kilometers per hour, but usually it moves in 50 kilometers per hour. So the wind flows nearby a subway, it is approximately 50 kilometers per hour. And also I found many designs of generator, and I choose this design named Savonier's wind turbine because it is easy to make. And if I use the fan design, there is a small gap between this ceiling and the subway, and the fan size will be smaller, and it can't make many energy. So I thought about using this the short and long wind generator. So I asked ChatGPT so how I can calculate the efficiency, and I got some equations that this is the power of the wind related to the air density, projected area, that is each wing size times number of wings, and related to wind speed, three times. So it is very related to wind speed, and also this changes into it turns generator, and also it is changed into electrical energy. So there are some constants that need to be added on, and this is the energy that it makes, the power times power and time. So I thought that making the generator spin faster is very important. So to make better efficiency, my first idea was using continuity equation. This is about the fluids moving. So if fluid moves in the smaller area, it moves faster to be continuous moving. So air can flow faster, and also the air moves one way, but it can also spin the upper side and bottom side of the wing. After I will show it. So I thought that this can concentrate the wind to one side of wing of the generator. Also, I thought about using belt drive, and it is applied to the prototype. I will show it later. So there is a angular speed of 2 gears, and there is a belt that are fixed in 2 gears, and their radius times angular velocity is the same. So I can use this method to make the generator spin faster. This should be continued to this slide. Sorry. So I made a tube for wind that one side is bigger and one side is smaller, and wind can move faster. It makes more rotation, and it makes more energy. Like this. So I used the Savonius type wing and this shaped tube to concentrate wind and also make wind move faster. So this is the example that I calculated, and I changed these values into the real life example. So this area, I got this calculation because this is about the metro line number 2 that goes through the Shinchon station. This is the width of the car, and this is the height of the car, almost 3 meters and 3.7 meters. And this tunnel's height is 4.5 meters. So I thought that wing, this size, the radius of wing, can be 0.25 meter, and it can be long as 1.5 meter, but it can be changed in real life. And I made a prototype for 4 wings, so this is the area. And I got this velocity because air has friction, and also it can't smooth like ideally, but it will be a little bit faster. So I got this number, and I calculated this electrical power as almost 1 kilowatt. So I thought that this idea can be useful because there are so many subways in Korea, in Seoul especially. There are almost 140 trains in Seoul line 1 to 8, and there are also line number 9 or some more lines. And also, I thought that this can be added on idea. This idea can be added on KTX moving tunnels or other trains. So this is attached on the ceiling of the tunnel, so it can charge a battery using the wires and the capacitor, because it can't make electricity constantly because metros are not so long. So it moves, it spins sometime, and it will be stopped sometime. So I can charge a battery and use it somewhere I can use, something like activating the screen doors on subway stations, lighting up the subway tunnel, or lighting up the LED screens at stations, or something else. So I will show my prototype. Wait a second, please. It is complicated. It has many pieces. Oh, can I use this again? So this is not same as real life ideal. So this is string that can move and work as a function as a the conveyor belt, and it is connected to a generator. And generator, if generator spins, it will turn on the LED light. So where I can get the wind is it is from my mouse. So look at the LED, please. Oh, sorry. It is not that good connected. It moved very better when I tried it at home. And I also tried, this is the USB port here. So I tried to charge my phone, and as it spins as fast as I can blow, it could charge my phone almost 1% per minute. So I think, and this kit is almost 30,000 won in Korean won. So if in real life it can make better energy.